All right, thank you everyone for coming back. This is our second seminar this calendar year. And as you know, one of the pillars of today's AI technology is the availability of large amounts of data. And at least in the computer vision field, one of the things that happened that really enabled this blossoming was the availability of large data sets that were annotated using crowdsourcing technology. And I'm talking about ImageNet, Visual Genome, ActivityNet, and others that really helped the field move forward. So crowdsourcing has been a very close field to AI, and we look forward to see how it continues to interact with AI. Potentially, when we see AI systems deployed and interacting with many people, they will probably also benefit from some ideas from crowdsourcing. So today we'll have Michael Bernstein present some of the recent developments he has been working on crowdsourcing, and we look forward to your interesting talk.
Thank you. Excellent. So for those of you who don't know me, my name is Michael Bernstein. I am an assistant professor here in computer science and a member of the Human-Computer Interaction Group, which means that in addition to trying to make computers faster and more secure and smarter, I'm also interested in designing them such that they're a better fit for human cognition, human abilities, such that they amplify our own cognition, make us smarter. And in particular, I'm interested in ways in which computation makes us smarter together. And I'm interested in this in part because the relationship that I've had with my computer has been pretty static for the last, say 50 years since Douglas Engelbart. And that was some sort of work or idea came out from the world, maybe from my boss, maybe from my advisor or whatever, and I would then turn to my computer, I would fire it up, I would hack something together, and the computer's job was to aid me in the doing of that work. But now all of a sudden we have the computer in a very different position. It's actually mediating work that's flowing between lots of different people. And if you want evidence of this, look at systems like Uber and Lyft, look at Amazon Mechanical Turk, Upwork, Freelancer.com. People are making careers over a network, right? And so just like before, when I could design how the individual computer worked such that it could facilitate the doing of whatever I'm trying to accomplish, I believe that we can now design this computational layer that's connecting people who want to get something done to people who are interested in doing it. And this is really powerful because it's the first time that this kind of thing has had a computer or any sort of mediating layer in the middle that we could design. So I just want to first give you a sense that this is going to be a big deal. Economists estimate that something like 20% of United States jobs could eventually be done online. That's on something on the order of about 45 million full-time people. So what would you do if you could potentially tap into 45 million really smart people digitally? So far what we've done as a field is take a bunch of people, treat them as generic sort of cognition units, CCUs I guess, and have them do things like label images, collect data, ImageNet as was mentioned, shorten text, things that really anyone could do. And my own group has done a bunch of this. We've looked at ways in which we could capture expertise from you in little micro moments. Every time you unlock your phone, why bother sliding? This is basically a CAPTCHA for your phone anyway, so why don't we capture something about like how many people are around or what you were up to? Or why not build interesting methods to scale this up? In collaboration with Fei Li and others, we've been developing techniques that will literally show you images at 100 milliseconds per image. Try to clap every time you see a man on a motorcycle there. You'll notice that you're going to be delayed and error prone. But if we get enough of you together, we can actually, thank you. We can actually start to correct for this and get an order of magnitude increase in the throughput of the labeled images. So we could build ImageNet in a tenth of the time, for example, by taking advantage of sort of our cognition. All of this basically has this particular characteristic that it's what you might call micro-task crowdsourcing. It's distributed, people work independently, they're low skill. I think this is not the future. I think the future of this is where computation is empowering much larger collectives to take on things that are complex, interdependent, require expertise. And what the computer in the middle is essentially doing is helping us coordinate our activities, figure out who we need when and for what. So there's a bunch of reasons why this shouldn't work. In fact, there's an entire field that documents all the reasons why this won't work. It's called organizational behavior. And they've spent, again, probably about the last 50 years, demonstrating all these cognitive biases that sort of limit us from organizing ourselves effectively. We are great at distributing work, but very poor at foreseeing how hard it's going to be to integrate our work later. Think about any group project you've been on. Most teams that try to accomplish something get essentially nothing done for the first 50% of their lifetime, and then get most of their actual work time done in the second half, etc. There are all these kinds of things that are patterns we fall into because we're not very good at thinking as people about how you create these little small changes that have an emergent collective behavior. But we have something that we didn't before, which, as I said, is the computer in the middle. So my goal, and what I'm going to show you, are ways in which we can design computational systems that can overcome a bunch of these biases, that can pull us together on demand to achieve really complex work. So I'll start with one example here that we call Flash Teams. So I stated that there are a number of goals I had about bringing together people who are expert toward complex goals and interdependent work. I'm going to focus on expertise for a minute, because nearly all the crowdsourcing that I've seen out there prior to this work was essentially Amazon Mechanical Turk, microtask kinds of things. And this really limits what we're actually able to achieve. We started with a different question. Could I crowdsource the entire user-centered design process, starting from a napkin sketch? It's like Sebastian had an idea right now, drew it out, hand it to me. Could I throw it into my system, and one day later have a working, user-tested, iterated system that he could play with? 24 hours. Likewise, could I crowdsource the creation of a short animated video in 2 days? And of course, I had a bunch of colleagues when I arrived who were off creating platforms for online education, so I figured, well, why don't I make a bad one of those? Could I crowdsource the entire platform itself, including the lessons, the videos, the tests, and so on, in about a day? So we set this out as sort of unachievable goals. We found they were somewhat more achievable than we expected when you think about it correctly. So we have thought about Mechanical Turk, right? Microtasks, everyone's the same. When in reality, we all have different expertise. Here I'll draw on a different, just as an example, Upwork, which is an online marketplace where you can, through an API, hire people with many different kinds of expertise. I've hired programmers there, I've hired poets there. Really, whatever you're looking for. And you could say, well, why don't we just hook into APIs, pull people together, and let them figure it out? Again, the organizational behavior literature is going to tell you that's not going to work so well. These are known as self-managed teams, and it turns out that, well, I'll just quote the literature. They are inefficient, riddled with frustrated members, and poorly coordinated. So again, think of your high school experiences or anything like that. But what's surprising is that only a little bit of additional structure, what are known as team scaffolds, where we're articulating specific roles that each person's supposed to play, and that there's a unified goal for the team, are enough to make these teams work really well. So our sort of design and engineering goal is whether we can design a computational system that can replicate and scale these kinds of insights. We call them, the system that we built, Flash Teams. Flash Teams are on-demand teams of experts that are convened automatically and then scaffolded through an automatic process to do something like take an input napkin sketch, run this team, get the right people, coordinate them in the right way, and produce, in this case, say, an implemented user-tested design. So everything here I'm about to show you relies on predefined workflows, which has all sorts of limitations. I want to say that off the bat. Only certain kinds of things can be sort of decomposed into these workflows. What I'm showing right now only happens at a small team scale. I'd be happy to chat about how we've been creating entire organizations at much larger scales. But let's first talk about what's possible with these constraints. So simple formalism. We have tasks. Each task has a sort of structured tag language of inputs and outputs. So if you give me a napkin sketch, I can produce a low-fidelity mock-up. It's parameterized by the kind of expertise we need, like a UI designer, and a length of time. So we know we have an input napkin sketch now. We know we want a high-fidelity prototype that's been implemented. And what we need to do is essentially pave the path in between by getting inputs to feed into outputs to inputs to outputs, right? And if we can structure it in the following way, then the system can help us. Here's what one of these actually looks like. You give me the napkin sketch, and you can see it follows sort of the user-centered design process that I might teach in my undergraduate course. We start with low fidelity mockups, get an expert to give feedback on it, revise it, start building the software, run a user study, revise it again, etc. Now, what's nice about this is that maybe for the first time, a computational system has like a representation of what people are trying to achieve. Usually, like when I'm working on a research project, we're just sort of huddling over paper. But all of a sudden, the system knows what's happening. So because of that, our system can introspect on that team composition, get the right people, and then convey people through that workflow. Everything I'm about to show is going to happen through workers that we hired off of Upwork. Since we have this representation, we can apply some interesting, in some cases, old school techniques to give these teams affordances that you wouldn't see in traditional teams. Of course, you can make them modular. So if I can design one team and bring in one, I can get K for any value of K just by hiring more people, right? So if I have one design team, I can make 3, give them different inputs, get different outputs. By the way, each of these examples are things I took from like week 3 of my undergraduate class, and then we fed them through our system. So thank you to teaching feeding into research. So because they're modular, we can also combine these teams, right, into sort of little like Lego blocks into larger organizations. So we might take design teams, join them with other teams that I'll describe in a moment to produce something that's emergently more complex. So there's modularity. In computer systems, we often talk about elasticity, right? We can parameterize these teams such that, well, by default, yes, what I've described is we need 3 developers. We don't always need 3 developers. Mythical man month notwithstanding, it's often possible to maybe start with 1 and then allow the teams to elastically grow and shrink based on the actual needs. Why would you do this? Well, one is sometimes these different napkin sketches require different amounts of effort, and sometimes you don't have the expertise you need. We need a logo designer, for example. A system can help that. Another computer systems thing that we can just draw on straight up is pipelining. So here's the workflow I described to you. It's pretty linear. But if you give me just one more bit of information or 2 more bits of information, which is that, okay, well, I don't need to finish my entire design before you start telling me what's wrong with it. And likewise, I can start telling you what's wrong with stuff as soon as you start giving me something. Can stream its output, can process streamed input. And at that point, our system can then essentially start to automatically pipeline these things. Now, the big win here is not necessarily speed, although it helps. It's actually, because these are globally distributed teams, we get them into the same time zone, more likely, which makes it much easier for them to coordinate. Here's a slightly more esoteric property of these teams. Suppose that Juan Carlos had a napkin sketch of Sebastian's idea, but he didn't want a prototype. That's the HCI thing. He wants an animation. He wants to do a Kickstarter, make lots of money. Well, we may not have a team that is predefined that knows how to do that. But I mentioned we have this sort of structured tag language behind each of these tasks. It may be possible that we have elements of previous other teams that we've seen before that could be synthetically woven together to get us from the starting point to the end point. And to do this, we're actually going to use some action planning languages from artificial intelligence, where you have your before state is essentially the thing that comes in, and the state of the world changes, etc. And if there is a path from what you want to where you from what you have to what you want, we can identify it. So a lot of sort of unusual properties of these teams. You could think about throwing them into Slack. Turns out most of these kinds of teams are not really well coordinated by existing tools, so we've been building our own called Foundry. Foundry allows 2 things. One is, as an end user, you can author these workflows, and then it essentially becomes a sort of runtime manager that helps help team members coordinate. So it tracks progress, keeps everyone updated, and so on. So if you were to author a team in Foundry, it would look something like this. You create all of these blocks. You specify the roles that you want. We connect again to Upwork to do so. You specify dependencies. The little arrows indicate that one feeds into the other, and so on. And when you're ready, it can sort of turn around, hire the people. And now let's say I come in and I'm a UI designer. It highlights what my responsibilities are here and downstream. I start working, lets everyone else know. Because I'm a professor, I run late. Sorry. So it lets everyone else know that. And then as I complete it, it sort of updates the workflow and so on. So Foundry is the thing that instantiates all of this. It allows people to author these representations, grow, shrink, pipeline, rearrange, hold a library, etc., recruit, and then coordinate. So let me give you a sense that this actually does something like what I've claimed it might. As I said, everything here is going to be recruited from Upwork. I'm going to show you 3 different kinds of teams. We took several different sketches of real applications that came up, again, in my undergraduate class, fed them through our system and the workflows, and you can see what here came out on the other side. It's not something that you want to deploy on the App Store tomorrow, but as a designer, iteration is key. And so if I can have an idea now and play with it 24 hours from now, it allows me to iterate extremely quickly through a wicked design space to identify something more effective. You can see these teams varied elastically from 3 to 5 people, cost about $1,000, and took about a day. Now, I know how to do this. Like I have a PhD in it. I want to do something I don't know how to do, which is make videos. So what we did is essentially reach out to a director on Upwork. So we hired someone to author a workflow in an area that we didn't know much about. You can see that it involved sound engineers and animators and script writers and so on. And we needed a video. At this time, my friend and colleague Terry Winograd was retiring, and so we decided to make a video celebrating his career. In particular, he tells a story of how in high school he built a computer in his garage. So we gave them that sort of rough prompt and let it go. And what I'm about to show you is the video that they produced. It's about 30 seconds. I guess the audio is not really hooked up, so you're going to have to listen to my poor laptop speakers. Before I start, if you don't already know Terry, you should know his sartorial style is somewhat Einsteinian. So you'll see a younger version of Terry in this video, and then his dad, who looks like Terry does now, will come and grab him. So this was about $2,000, 4 people, 45 hours.
Son? Oh, hey, Dad! What the? What is that? It's the future! It works!
So I noticed the Emmys nominations came out and I was overlooked. But, so these were people who had never met before, may never meet again, but came together and were scaffolded through this computational system to achieve something like this in 2 days. This honestly surprised me that it was possible. So a third piece here, I was mainly interested in seeing whether we could compose these teams together to achieve a more complex composite result. So we took 3 design teams, one tasked with creating a homepage. In this case, another one would be like a course page and an upload administrative page. We took these animation teams that I described and paired them with what I'll call here an education team, which was for each area, someone who was an area expert, as well as someone who had a background in curriculum design, right? And we composed these teams to create a series of 3 lessons, as well as a platform that would present them. These included singing from the diagram. I wanted to go for useless skills, by the way. Singing from the diagram, how to do portrait photography, how to the computational complexity of the Towers of Hanoi problem, and so on. So each of these videos were much shorter than you would see in a traditional course, just due to budget constraints, because I'm a professor and not a business, and I'm more interested in the performance of the system than the money per se. But you can see the videos that they produced. They hired on the left with this diaphragm singing, they hired someone who was a singer in the Frankfurt Opera, for example. And they were relatively high quality videos, happened fairly quickly. Now, these are all sort of proofs of concept. Accenture saw this and decided to try it internally, which as a researcher always makes me go, because things that work in the lab don't always actually work. In this case, I just want to sort of report what happened. They tried to do 3 things with Flash Teams. They tried to make a marketing video that had to meet their own internal marketing standards, made a mobile app, and a business development video. And again, I am the worst at business. But what they told me was that there was, the results achieved their goals at about something like 1/7 the cost of their own internal agency estimate, including the cost of the time of their own internal employee. So I don't want to get into like there's clearly wage arbitrage going on here, but what's actually happening, and that interests me much more, is how well the system was coordinating people toward this goal. And to get at that, we ran an experiment. So we thought that what was going on was that Flash Teams were essentially helping people coordinate efficiently. So what we did is we generated 6 teams of these napkin sketch design teams, as I described. 3 of them were Flash teams. They saw everything as described to you. The others were what's known as self-managed teams, which meant that they were able to sort of do whatever they wanted. So we brought them together. We say, go. You're in control here, not the algorithm. We had them. We gave them a napkin sketch. We gave them a time limit. And then we measured how many collective work hours it took them. So you can imagine we can either set time and measure quality, or set quality and measure time it took to achieve it. We chose the latter. So we chose to set the required quality and then measure how long it took to do it. So if you were in a Flash team condition, it's exactly as I described. If you're a control team, you just basically got a big block and you could use it however you wanted. What we found was that the Flash teams took half as many work hours. Same conclusion, equivalent people, half as much time. And in fact, the slowest Flash team was faster than the fastest team in the control condition. And what was really happening was that in this control condition, everyone was sort of running their processor hot all the time. You had UX researchers who were trying to do some coding, but they're not very good at it, causing coordination challenges. Whereas, again, in this Flash teams, the roles were much clearer, so things were a bit more smoothly coordinated. Now, what do you trade off? These Flash teams were, of course, not as good at dealing with contingencies. So if we needed to go back and something wasn't done correctly, the system isn't very good at that. Whereas these self-managed teams could sort of be fluid. So this is something we're working on now. But at the highest level, what I want to sort of convey, and what I've been really trying to get across to the research literature, is that computation can offer us an opportunity to crowdsource really complex goals together. That we can look beyond this sort of microtasking worldview and think about how we might create the next world wonder together at scale. Again, this only works with things that you can decompose, which is a small subset of complex work. We're doing some stuff right now that's thinking about how these teams can adapt as they work, change their goals, change their structures, and so on. These only work at a small team scale. Things that are complex and open-ended need other kinds of infrastructures. So that's Flash teams. What I'd like to do at this point is cover a bit more quickly about sort of the socio-political outcomes of this and what kinds of systems we could build that imagine this a bit more fully. Now, how many of you have used Mechanical Turk, by the way? Great. So Mechanical Turk, if you don't know it, is an online work platform where people will do small tasks for small amounts of money. And crowdsourcing sounds very sort of democratic. Anyone can do it. But on the other hand, what's actually happening is that we're building systems like the one I just showed you that sort of hide the workers. At no point did I show you a person's face with the Flash Teams project. And this can be problematic. You could say, well, why aren't they unionizing? My student Nilafar Salehi, who is doing amazing work and now can't leave the country, spent a lot of time working with Turkers on their forums, and there's a real independent streak to workers here. And so if you say, why don't you unionize? They are not interested. They say, I'm here, I'm my own person. And you can see the same thing happening with, say, Uber, right? Where workers view themselves both as, like, I'm an independent person, I'm an independent contractor, I own my own life. This is just an app. And wait, I'm under the thumb of a company. So it's this kind of ideology conflict that's really complicated. So we thought about whether it would be possible to start creating systems that would allow these distributed workers to come together, make their voice heard, push for change. The system we created was called Dynamo. We can take all sorts of social computing techniques. I'm a social computing researcher, so people can pitch ideas, upvote. If things get over a threshold, they can discuss, and then they can mobilize. And it would be amazing if this worked. This does not work. What was really necessary was to help people get over friction. Think about trying to come to an agreement over email. It does not work well. So what's actually surprising is that you could sort of follow what I would call human scripts, so to speak, where if things are flaring into acrimony, you simply set a deadline. You say, yep, you can fight about this, but we need to come to a consensus by 2 days from now. And this forces convergence at the end of the day on many issues. And if things are stalled, what you do is you do something bad. And people are much more willing to contribute and improve something bad than to take that first step themselves. So a neutral moderator can say, okay, we're stuck, sure, how about this? And then people start getting into it. Once we started doing this, workers who are Mechanical Turk workers using Dynamo did all sorts of things. Ironically to me, the first thing they did was go after academics who were rejecting work not fairly, who were not paying enough, and so on. They created a set of guidelines for academic requesters that are now used across many different IRBs across the US for how you should be working with Mechanical Turkers. They also wanted to take control of the media narrative around them. So they started a public letter writing campaign on Dynamo to say, hey, Amazon CEO Jeff Bezos, these reporters come every once in a while and say, poor Turkers, poor Turkers. I'm here, I'm not a poor Turker, let me tell you my story and what I actually need. And they wanted media coverage, and they managed to get it out of this. You notice that the word union is not here. I think it's interesting that they started calling themselves a guild, something about the labeling there. So you can connect that also with needs for like career growth and learning and skill development. So the model that these platforms take right now, like Upwork, is that like you are a sort of level 2 Python programmer, and you should be able to get those kinds of tasks. But in our lives, we are constantly learning new things, growing our skills, and the problem with how these platforms are architected right now is that people don't feel like they can do that. They say, if I'm not working right now, I'm losing money. So they don't have the ability to actually stop working in order to learn something. So we thought it might be intriguing to pursue an idea that we call micro-internships, where imagine that you took something like off of Sebastian's platform to learn a skill. You don't have any experience yet, so you can't actually get jobs in it, because you're competing against people who have a lot of experience. So we take tasks off of these platforms, connect you, as the newbie, with someone who has more experience, who becomes a mentor. You split the pay. The mentor makes as much as they would hourly normally, and you make a lot more than you would be because you're taking up a more complex task. And you're getting mentored. You're getting deliberate practice feedback as you go. So the mentor takes this specific job that someone wants done and is willing to pay, and they break it down into a series of steps and sub-steps. They offer office hours, etc. And you, as the mentee, start working on it. As you make progress, you can get feedback. So at a high-level schematic, what happens is that the requester posts this job offering money. That gets granted to a mentor who has experience. They break it down. You come in and you start working with that mentor on this thing, getting feedback. And when you're done, the mentor reviews it to make sure it's high enough quality for this requester, and then submits it back. And then the two of you essentially part ways. So at a high level, what I just want to indicate with these two projects,
we launched this under the name blitz.com
Nice.
In November, and with the only modification that in the end the intern gets hired by the company.
Excellent.
As a trial.
And
Great.
Great. And what's the outcome for you been?
The NPS is about 92.
Mm-hmm.
The hiring rate is low. It's probably not 50% or so.
What I found
But what we find is that startup companies love this because they have tons of stuff to be done. They can't find talent.
Right.
And then in the world, there's amazing talent out there.
Right.
No one hires because the CVs don't look very proper.
Right.
If you take a degree that doesn't really give you credibility in the field,
Yes.
as much as we want.
Yes.
So it's a great way to try people out.
I can tell you what the hardest thing for us was that these interns often overestimated their abilities. So they come in and say like, hey, yeah, I'm good at this. And then they see the actual task and they go,
They also
whoa.
they don't know how to communicate, how to organize.
Yes. Communication, like language barriers, is always a challenge with these kinds of things.
Cool.
So yeah, I mean, this was something we did back in, I think, the summer of 2015. I would love to get a sense of what it's like at scale once deployed.
You're aware of the work, but we should be aware of your work.
Well, and likewise, this was my oversight as well. So more to come, clearly. I want to close with
Very cool.
one of the more ambitious projects I've taken on recently. Okay, so this is ongoing work. I had a moment where I was observing, I think we had just landed a satellite on a comet. And you saw a picture of a bunch of scientists jumping up and down. They had spent years on this, working on it together. Right? Hundreds of them. And then I walked here the next day, and I was like meeting with one of my graduate students. And it seemed weird that we have these huge goals that we can achieve together in some domains, but like in many others, it's like we have these very micro visions that we try to achieve. So I was wondering, why do we have to restrict ourselves to these research problems that are only solvable at very small human scale? Likewise, there are people around the world who have the motivation, the time, the energy, the skill, the work ethic to contribute, who simply do not have access to Stanford faculty, to any R1 faculty, right? It seems like there was a weird imbalance there. So we started wondering whether we could enable people around the world to work together to do things like build an entire new crowdsourcing platform. They're all broken in their own ways. Or to design not just one experiment, could we run hundreds in parallel if I were a social scientist? Or develop entirely new kinds of computer vision algorithms. Now you may be familiar with things like the Polymath project or Foldit, which brought together people to work on science, citizen science. The reason that these worked is that they had well-stated goals at the beginning, right? They said, we're going to fold this protein, or we're going to prove this thing. I'm going to argue science does not work that way. In fact, Gowers himself has a book about how this is not how math works. That open-ended research, you try something, you adapt, you evolve. There are very few problems in research where you can completely predefine the path to success. So when we have this felicitous approach, so we said, well, okay, we don't know how we would scale that kind of research. And in fact, even if we could, I have like 8 students in my group at Stanford, and I'm really busy. Google managers are said like no more than 7 reports. How the heck do we run a lab with thousands of people? So I said, yep, that's a problem. Second problem, credit. Eventually in computer science, the norm is to have an author order. These people who are contributing are going to want recommendation letters to help them achieve upward career mobility. How the heck do we take this interdependent problem and assign credit and say you would be first author and you should get into MIT and Stanford, or you contributed but maybe not quite so much? So we said, yes, those are problems. Let's do that anyway. So we put out an open call. We had a series of projects. In the initial sign up, we had about 1,000 people. We're now racing far past that. You can see the project that I led was about 50-50 men-women signups, but the computer vision one was far more skewed toward men. A lot of people from developing regions, mostly undergraduates, current undergraduates, or people who had recently graduated. We ran 3 projects. One is mine, creating a new crowdsourcing marketplace, designing better reputation systems. We have some incentive-compatible crowdsourcing stuff going on. Second one was run by Serge Belongi and James Davis, who the computer vision folks here might recognize. They were interested in hybrid algorithms that would combine computer vision with Mechanical Turk. And then my colleague Sharad Goel here in Management Science and Engineering wanted to test the wisdom of the crowd and when it holds and when it doesn't. Why can we guess the weight of an ox, but not the number of jelly beans in a jar? Could we guess which direction the penalty kicker is going to kick, right? What are the conditions under which this works? So they generated hundreds of experiments testing whether it worked. So we generated a sort of computationally powered coordination strategy in which we essentially allow divergence during the week, peer assessment that allows the identification of the best stuff, and then reset to argmax at the end of the week. I'll explain what that means in a minute. Essentially, once a week, we have it's now called YouTube Live, Google Hangout on Air, in which we are, see you. Of course, see you. At which we allow anyone to join, we talk about the project, and then we give people a week to contribute. We then have peer assessment where people are sort of rating the contributions for that week. And then the staff collates the best ones, and we use that to design the next week's milestone. So when we're diverging, everyone who wants to can submit to the milestone, and then they go into a system that's basically a clone of Reddit and upvote the high quality submissions. That works great when you're trying to generate lots of ideas. When you're trying to actually execute, what we end up doing is empowering active community members to lead certain sub-efforts. So I would say, Juan Carlos, you've been really great at this AI stuff. Why don't you lead that part of the milestone this week? And he might create ad hoc meetings and chats in Slack, and people pull things together. So it becomes much more iterative. So this is how we coordinate. How do we deal with credit? The intuition is that we actually turn this into a network problem. So credit, really hard. Graphs, we know a lot about. So what we do is we give every participant 100 points. Participants are allowed to allocate those points amongst everyone else in the group based on how much of an impact they think that person has had on the project. So if I think that Rob has had a ton of impact, I might give him fully 15% of my credits, right? I might give myself, actually we disallow giving yourself anything. I might give you 1 if I haven't seen you around, et cetera, et cetera. Adds up to 100. So we get a sort of a weighted directed graph here, right? Where the nodes are people and the edges are the credits that they've assigned to each other. What we do is we then use network centrality measures. So we take this graph, we find authorities using a modified version of PageRank. We modify it in 2 ways. One, PageRank sort of says there's a link from X to Y or not, whereas here we have essentially proportions. So we now modify the algorithm so that it's percolating out the PageRank in proportion to how much you gave each person. We also do some stuff to manage some strategic behavior. Informally, what this does is it identifies the people who everyone respects, so everyone gave Rob a lot of credit, and the algorithm listens a lot to what Rob has to say and weights up his opinion, and then iterates until convergence. That's how PageRank works. So we deploy this. We have huge Google Hangouts, a ton of Slack usage, the biggest Trello board I've ever seen, a lot of use of GitHub, a lot of use of prototyping stuff. Here was Serge's project with some data analysis. They were writing papers. We also connected participants with researchers so they could understand what life is like. So Andrew, Peter, and Anant. So they had Q&As with these participants. It's been about a year, maybe a year and a half since we've launched. We've had the crowd wrote a paper at a top-tier computer science venue. In fact, now 2. This is a little bit out of date. WIST and CSCW. Something on the order of 40 co-authors on each paper. Much more happening. Contributors have gone on to graduate programs at Stanford, MIT, Cornell, and elsewhere. Here's an example of what such a paper would look like with a gigantic author block. This one was interested in how to deflate reputations in crowdsourcing platforms. So what they did is they created something that's sort of roughly incentive compatible, so that if I give a worker a high rating, that worker then gets early access to my future tasks. So if I take someone who's bad and I gave them a high rating, I'm dooming myself to bad work in the future, right? So the effect that this has is it deflates the reputation signal so that the top people are actually at the top rather than all clustered together. So we've been investigating sort of what's going on. People tend to last about 10 to 12 weeks. This big spike is when we opened up another set of recruitments. One of the projects, mine, has been going for probably 100 weeks at this point, and people are continuing to contribute. The crowd does write the paper. So what we did is we took the edit history of this paper that was submitted, and we broke it out as to whether this edit, like an insertion or deletion of a block of text, was created by the crowd or by me in this case. And you can see, alternate title: Michael loves editing intros over here. But the crowd made about 80% of the edits on the paper. So it wasn't just like, thank you for your work, I'm going to go write the paper in.
Michael, do you think that's right? Did you spend your time in the intro?
Absolutely. I mean, what I'm good at is framing.
Right.
Right.
I mean, the workers know what happened in the study. Right? They don't know all the background.
I mean, I teach it to them as we go, but ultimately, like, I'm the one who has the experience in writing this kind of paper and framing like what the diff is off of the related work. You can see they wrote a ton in the intro as well, but it was more of me like mentoring. It was much more like me mentoring a first-year PhD student, where like they're taking a few whacks and I'm sort of giving them a lot more hand-holding than I would. I think first-year PhD student is a good mental model for what it's like in the collective. Needs a lot of hand-holding, but a lot of energy and a lot of ideas. So here's the sort of author network. The width of the diameter of the node is the amount of PageRank. So you can see that our top author was up there in the upper left. He was pretty universally respected by nearly all of the other co-authors. I want to point out there was some strategic behavior going on with this node here. So worldwide, there was a team from Central America. Most of them did not speak English. This member did, and became the sort of interface of this entire team with the rest of the crowd. So what ended up happening was that when we were asked, who do you think had an impact on this project, these teams, you can see the width of these edges, gave all of their credit to this one individual and not to anyone else, because they had never interacted with anyone else. And if you just summed up the raw votes, this person would end up being first author. But again, tools like PageRank can start to soften the effect of linked rings and correctly identify that this person in the upper left was actually the much more universally respected. So what's interesting about this to me is that we're not determining credit and performance evaluation by like just who's your manager. It's actually sort of determined collectively by the entire group. So I'll wrap up here. I think what's happening is that we're seeing a future of work that is computationally mediated. And because it's computational, I'm excited because I get to think about what that design is going to look like for those systems in the future. I want to move away from a world in which people are sitting as like click workers doing really boring stuff. I know that AI really relies on them, and I don't think that they're going to go away. But I think that like actually a pro-social outcome here is going to require us thinking about how to achieve much more complex and interdependent goals, to create systems that can help workers advocate for pro-social outcomes, and to move away from this notion that we have to like know exactly what we're doing when we're starting if we want to go after crowds, and instead go after much more open-ended challenges. So I want to thank many people, graduate students, of course Toyota for helping fund actually the creation of this platform that I've been hand-waving around, this new crowdsourcing platform that we're creating to help generate the data for all of these AI systems that you are all building is largely, in large part, being helped through this Toyota grant. We hope to launch it soon. We already have been working with my colleague Percy Liang to create some question answering data sets that I think just won best paper at EMNLP. They used our platform. It's looking good. So we're excited. If you all have data needs, I would be happy to chat with you about how we can collaborate on that as well. So that's all I've got. We end in what, 10 minutes? Or yeah, I'm happy to have a conversation.
Questions? I have a question to start.
Yeah.
So the first part, I guess the granularity in which you divide the task. I mean, your goal is to achieve, complex
Yes.
tasks at the end, but you still need to think about what granularity you want to divide the work in.
Yeah.
So your workflow and pipeline really ends up being also a set of micro tasks, or is it like a bigger?
In a sense, yeah. So I mean, I think they're macro relative to Mechanical Turk, and they're micro relative to what a designer might do if they had a design consultancy, right?
Right. So I guess my question is whether those components are a little bigger than the usual thing we do in micro tasks, or are they still at the same resolution?
I think it's about your level of zoom here. So
right.
creating
So right, exactly. So what I'm saying is because if you don't zoom in, you just have this very wide view, then you get very inefficient work, which is your control block.
Mhm.
But then once you zoom in, then you get some benefits. So I'm assuming that the level of zoom affects the benefit of distributing the work.
Yeah, so you have a sort of Goldilocks issue here. Like if it's broken up too finely, then the workers don't have any autonomy or ability to make decisions, right? So then it's easy for things to go off the rails, right? It's like a game of telephone where something goes wrong up here and they can't fix it because the workflow says, nope, got to keep going. On the other hand, if you don't break it down at all, you end up with essentially self-management, and as you saw, coordination is less effective in that context. So yes, there is sort of a middle ground that you have to seek. I think the same thing happens when you're designing Mechanical Turk tasks, frankly. Yeah. Justin Chang in my group demonstrated that sort of the more finely you chop a micro task, it makes it slows down the work, but it makes you more robust to interruptions. So what ends up happening is, if you chop it up more, right, like add up each line of this receipt incrementally, or identify each object separately and verify it or something, you deal better if like something else comes in the middle, but it takes longer, which ultimately, I guess, for you who's collecting the data, costs more. Right. So in some sense, the better strategy is to identify high quality people, give them less constraints, and just let them go.
That's interesting. Any other question?
Yeah.
Can we crowdsource a research that improves crowdsourcing?
I mean, that's sort of what we did, right? Like this project here is a crowdsourcing project that's creating a crowdsourcing platform. So yeah, I'm eating some dog food here. But yeah, I mean, I think the crowd itself had a lot of ideas about how to improve the crowd research project or process, some of which we've integrated. There were a lot of ideas about creating like little local groups, for example, or finding ways to connect people who speak different languages and so on. So yeah, I think you could certainly bootstrap the system if that were your goal. I call it rapid iteration. You might call it self-improvement. But absolutely, yeah. And I think Rob, yeah.
I just have two competing thoughts about what this means for the world. One is I just worked with Kessler on his design data, and kind of novices were good enough. It was kind of one of his findings. So the expert novice thing is kind of troublesome as a concept. But on the other hand, there are skills that people have, and it seems like you'd be able to identify gaps in the skills. We have an engineering shortage. It says President Obama, so we need more people in STEM. But if you look at the pay rates of STEM people, they're stagnant, just like everybody else.
Yeah.
So the data is very confusing, and it seems like in this kind of this task area of UX design, you would be able to say something more definitive there. Are you kind of thinking along that ways long term, or do you expect someone else to pick that up and run with it?
To make sure I'm understanding, are you asking, can I tell you how much you might make if you learned UX research or something like that?
Or there's demand for this. You would graduate with and be able to get a job.
Yeah.
Not have to go to law school.
Right. So two thoughts on this. One, a colleague at NYU, his name is John Fortin, has analyzed the entirety of the Upwork data set and actually saw these skill transitions. You could see people who used to do this, then like started doing jobs with these tags and then these ones. And because if you're Upwork, you can see the entirety of like the demand and the supply as well, right? So what you can do is you can say, hey, there is a lot of undersupply of UX research right now. This is the path you would need to follow to get there, and here's how much you'd make once you started doing it well. This kind of thing, yes, absolutely, I think systems could start to do. So that's the first thought. The second one, a little bit closer to home. I've been involved in a project here at Stanford called CARTA, which was about taking sort of a complete data set of like 50 years of student behaviors and trying to identify sort of pathways through the university and return some of that information back to students, right? And one thing that I'm really interested in doing there is connecting these short-term decisions about which class do you take with long-term career outcomes, because we have longitudinal data now. We can go to LinkedIn, find out what happened to these people, and then say like, look, people will say things like, oh man, I got a B in the computer vision class. Can I still work in AI? And we can be like, yeah, here's like the paths that such people took. Or maybe like, well, maybe you could, but you should go do this kind of other kind of AI instead, right? We could actually connect those short-term behaviors to longer-term outcomes, which in my experience, people tend to be very risk-averse. They look for like, what's the standard path I need to take to get there? Because that's it's sort of like the the eigenvector. It's like the thing that stays that you hear about the most, because like everything else is sort of just like one-offs. But maybe we can aggregate that over much longer periods.
Or make it true.
Yeah. Well,
sometimes the stories aren't always.
That's right. Do some myth busting. Yeah, we've done some. I'll see that. I'll get you in a sec. We've done some interesting myth busting, like working with Dean Saller in Humanities and Sciences, Dean Drell now, I guess Provost Drell. Well, tomorrow, next Monday, she's Provost, and and they're interested in these questions. Dean Saller is like, look, we tell our undergraduates that they can major in humanities and get great jobs. We have no data on this, and we should either like, well, they have some data, but it's like not really as secure as they want it to be. Sorry, I should be more precise there. And he's like, look, we should either, be able to support this more firmly, or stop saying it and just say like, look, humanities is great for many things, and stop pitching that like, great jobs are like the reason you should go into it. So myth bust, I think would be really cool.
Last question?
Yeah, I think it's a kind of related question. So, like, putting aside for a moment the preference of people, right? But could you imagine to exploit this to also guide and optimize education, like such as skills, depending on what the needs are, or things like that, right? So,
yeah. So the question was whether you could, putting aside whatever the person wants, sort of guide and optimize education, right? So nudge people towards certain things. My general observation is that when you take away agency from a human, they tend not to like it. Now, there are certainly, I have no objection, and I don't think most people would have objections toward being aware of, like, information is powerful, right? Like, you could force people, but it might be more effective to just be like, look, you're going to make a lot more money here.
yeah,
Right? Like just, it's invisible information about the market that we can design systems to be much more effective at, right?
Mm-hmm.
And there are more and less obvious ways to do this. You can just show them visualizations. You can start returning search results that are like skewed toward the things that you think they might be interested in learning next, sort of like a recommender system approach,
Mm-hmm.
right? So a lot of different things that are feasible here. So the short answer is yes. The long answer is be careful.
Wonderful. Thank you.
Thanks.